Welcome to July 27th LeetCode Challenge. 3 sum closest. Given an array nums of n integers and the integer target, find 3 integers in nums such that the sum of is closest to target. Turn the sum of 3 integers. You may assume each input will have exactly one solution. So, given the array nums here, you have a target of 1. You want to take the sum of 3 of the numbers that will be closest to target. So the sum that is the closest to the target would be, if you take -1, 2, and 1, you get 2, which is the closest to the target. So essentially, you want to take, that's the gist of the question. The constraints are less than 3, of course, and greater than less than 10 to 3. Nums is within this range, target is within this range. Alright, so the classic approach to this, I think, is there's 2 ways of approaching it. One of them is using 2 pointers, and the other way is using a binary search. At least those are the ones I know about. So my intuition is going with the 2 pointers. So basically, you want to have a number scale here where you keep track of your 2 pointers, and then you keep on moving your index I. You have index I which you iterate through, and you have a left pointer and a right pointer, and then you just keep on keeping track of those 2, and then find the sums as we go along, and search to see if they meet the requirements or if this is the closest. So let's go about doing that. So the first thing we want to do is let's see. You want to sort the nums array. So nums.sort. Next thing we want to do after that is define a variable that is going to hold your solution, your answer. I'm going to call it closest sum, because that's what it is. Closest sum is going to be assigned to be none. So in the beginning, we don't have the closest sum yet. We're going to find it. And then we're going to find the length of our nums as well. I call that n length of nums. Alright, so we have those so far. Next thing we want to do is we want to iterate through our list, our nums array. So for I in range of n minus 2, remember it has to be within the bounds because we need to take 2 numbers out of it as well. The first thing we want to do is make our left pointer and our right pointer. Let's go with left. It's going to be assigned to I plus 1, and then our right is going to be assigned to n minus 1. That makes sense. We have a left pointer and a right pointer, and those are the assignments. So next thing we're going to do is do a while loop. So while our left pointer is less than our right pointer, left is less than our right pointer. That means that they're on the proper path there, because we don't want to iterate through having the left pointer go all the way to the right and the right pointer go all the way to the left. It's going to take too much time and not needed. So while left pointer is less than our right pointer, what we want to do is create a temporary sum that we're going to hold the number in. So call it temp sum. And that's going to be the number at index I plus the number at index left pointer plus the number at index right pointer. So basically, we want to take right. So we're taking the sum of 3 of the numbers at I, left and right. So basically, we're going to iterate through this and see whichever one meets the condition for each I. So if, I'm going to do a couple of if-else statements here. So if the closest sum is none, then what we want to do is return. No, actually, we want to make closest sum assigned to be assigned to temp sum. Else if the closest sum is none, then we want to basically make temp sum assigned to close sum, because there's nothing else that's closer than that. Well, this is for our first one. This is our first case entry case, because initially it's going to be none, and then we have temp sum being assigned to closest sum. That's just the first entry point. Then the next thing to do, it's just like a fail safe in case you don't get nums or if nums does not exist. So if the absolute value between target and closest sum is greater than the absolute value of target minus temp sum. So we work this right here is trying to find basically if the absolute value of the target minus closest is greater than the absolute value of target minus temp, then we want to reassign closest. Then we know that the closest closest sum is going to be our temp sum because that's closer to it. However, if our temp sum is equal to our target already, then we're good. We're golden. We don't break from that. Else, what we want to do is if temp sum is greater than our target, oh, I was going to say less than target. Then we want to do is we want to reassign our left pointer. So we're gonna increment our left pointer. Else, we are going to reassign our right pointer to be decremented to go down. At the end of all this, you want to return closest sum. Alright, let's see if this is on the right line. I'll run this a bit. Probably a mistake somewhere in there. Finish 2. Let's do it. Yes, never get it right on the first try. There you go. So this is using a 2-pointer technique. It's a bit challenging, but understandable. We basically initialize, we sort through the input array, and then we iterate through the array with using our index I, and we have 2 pointers, and then we just keep on moving the index I for each time we move the 2 pointers, and finding the temp sum, and we just make sure that it checks out with all these types of conditions, right? So if the entry point is for the first time it is none, then we just make temp sum equal to sum. If the absolute value of target minus closest sum is greater than the absolute value of target minus temp sum, that means that temp sum is better be the closest sum is should be reassigned to temp sum because it's closer. Or if temp sum is equal to target, awesome, we're done, break out, and return. However, if our temp sum is less than target, we're going to move our left pointer to the right, else we're going to move our right pointer to the left. And that's pretty much it. Time complexity is big O of n squared, because you have a for loop here, and we have a while loop here, but which might have to iterate through going through an outer loop and an inner loop, going through n elements at most. So the sorting array itself, so that's the algorithm, but the sorting array itself right here is takes big O of n log n times. So overall complexity is actually big O of n log n sort algorithm plus n squared for this algorithm right here. So it's which is like which is gonna be asymptotically equivalent to big O of n because the n log n one is just so small. The larger the number, this entire chunk here will take over. So it'll be big O of n squared. Space complexity is space complexity would be between big O of log n to big O of n, because yeah, right. Well, let's just call it big O of n worst case scenario because this is a sort algorithm. So space complexity is going to be all this if everything is there. Alright, that's it. Have a great day, guys.